Under the guidance of Professors Peter Sayeda and Dick Haskell, students Felix Pang, Amy Lee, Annika Sharma, and Katie Chang, all class of 2028, and so if you do the math, these are rising sophomores, sophomores right now, were recognized on the national stage when their idealPV team won the $20,000 prize at the U.S. Department of Energy's EnergyTech University Prize National Pitch Event. This is a prestigious competition showcasing the most promising student innovations in clean energy. And we get to hear their pitch today. Please welcome our students.
All right. Hi, everyone. We are Team idealPV, a solar safety innovation for the Department of Energy's EnergyTech Prize. I'm Felix.
I'm Amy.
I'm Annika.
And I'm Katie.
And our advisors are Prof. Saida and Prof. Haskell, who is also in this room today. So we found this opportunity through the Department of Energy's Office of Technology Commercialization newsletter, and they offer funding programs through the American Made program. And for the Energy Tech competition specifically, our goal is to make a commercialization plan for a high potential energy technology. This could be National Lab IP, but we decided, hey, if Harvey Mudd professors are so accessible, then let's choose Prof. Saida's research.
So we approached Prof. Saida and started working on this project since last December. We talked to different stakeholders asking for their insights and feedbacks. And every one of us was responsible for different parts of the project. So after becoming the finalists, we pitched our final pitch presentation at Colorado. We were the youngest team among all the finalists. Most of them are graduates. And we received the Solar Energy Bonus Prize issued by Department of Energy and received $20K as grant.
So now we'll be running through our pitch. And the check we chose is idealPV, the airbag to the solar industry, because it solves a key safety issue that all solar panels have right now, hotspots. Anything that causes partial shading on solar cells, so this could be birds or leaves, causes the cells to enter into a reverse bias state, meaning that they onload voltage from other cells instead of offloading it, causing them to heat up to over 200 degrees Celsius, which is a fire hazard. This matters to us because we live in a fire-prone region. The picture on the bottom right here was actually taken from Drinkward Dorm.
So solar panel fires pose an issue not just to people like us, but also to larger solar manufacturers due to the expensive lawsuits and settlements which arise from them. To quantify the problem, we understand that fires are severe. The LA fires in 2025 alone had an economic impact of about $131 billion. As solar panel adoption rates increase within the US, we expect the number of solar panel caused fires to also rise. But to be honest, this is just the tip of the iceberg, because the problem right now is that solar panel fires are categorized in the other category of fires in the US, so we don't actually know the true number. We went to Station 62 nearby to talk to the firefighters and understand how they interact with solar panels today. And we understood that when solar panels are present on a roof, firefighters can't go anywhere near them because of the electrocution risks associated with that. This prevents effective firefighting, and they can't ventilate the house properly and access anyone inside. So long story short, solar panels spark deadly fires as well as prevent effective firefighting.
The technology that we chose to focus on and build this plan around solve both branches of this core problem. idealPV hotspot prevention panels. This is a technology that we came across and found, as mentioned before, through research overseen by Profs. Haskell, Saida, and Yang back in 2022, and evaluating the efficiency and technology behind idealPV. So how does idealPV work? Well, idealPV's solar modules monitor dynamic conductance, which is the slope of current over voltage. And as dynamic conductance gets small, that's a sign of approaching reverse bias, which, as we mentioned, we don't want, because that means that hotspots are in your future. And instead, idealPV's module controllers drop current demand in response to accommodate to shaded cells operating at a lower photocurrent. And so, with this technology, hotspots simply don't occur, and firefighting on homes is made miles safer because they can be de-energized within a millisecond. And so for this whole plan, the end goal was to have idealPV be this industry standard for widespread safety. Some of the unique values that drew us to this innovation that are evaluated by the research are that they 100% protect against hotspots because they're preventative and not mitigative like solutions that currently exist out there. And because they're safer, they use quarter-sized cells, which means 3 to 4% less wire power losses. And so combined with their longer lifespans, they can produce up to 71% more power than in a conventional lifetime of a panel.
And the solar industry is growing at an incredible pace. In 2024, we saw 599 gigawatts installed, and that's a 35% increase from 2023. By 2026, there could be installing 1 terawatt per year, averaging 36% CAGR annually. And we have a huge market. Our total addressable market is the global PV market, and our serviceable available market, which is a safety-focused segment, about 52 billion. And our serviceable obtainable market, which is the near-term achievable goal, is about 2.09 gigawatts.
Considering the major safety concerns associated with solar panels, our main goal, as Katie said, is to make ideal PV the new industry standard. We approach this through a 4-stage implementation plan: demonstrate, deal, develop, and distribute.
So our first step is to run a pilot with Chirp, a nonprofit solar manufacturer based in Claremont-Pomona region that builds local factories in disadvantaged communities, creating more jobs. Ideal PV is already being licensed to Chirp, and we've spoken with their board about performance data and future partnership plans. So this collaboration will both allow us to evaluate panels' performance and contribute effectively to the community around us, one which is burdened by pollution and socioeconomic factors as seen on the CalEnviro's green report below. And the second phase of implementation involves reaching out to large solar manufacturers to highlight the benefits it presents to them through loss prevention and better community engagement. We reach out to the CEO of a clean tech consulting firm and a director at LA Clean Tech Incubator, who guided us to programs such as Founders Business Accelerator to connect us with larger firms, as you can see on the graph to the left.
The third stage of this process involves iterating and developing on our technology based on feedback from our customers, solar manufacturers. We will do this by benchmarking our technology on key performance indicators. This will involve lab certifications, profitability, and adoption rates within the Claremont region, as well as retrofitting. Ideal PV panels are currently designed in a way which they can be retrofitted onto existing solar modules. This increases the scalability of the idea itself. The last stage in this process is distribution. We aim to distribute the technology to larger solar manufacturers to outsource production to them and make production widespread. This will be done through a phased licensing model, and it benefits solar manufacturers as due to lower costs and simpler internal architecture, solar manufacturers actually save $1.5 million for every 100,000 ideal PV panels produced. This phased licensing model was recommended to us by a senior manager at the LA Office of Sustainability.
So here's our financial projections. In just the first 3 months, we licensed 300K and bring over 200K in profit. A large factory can produce around 8 million panels a year. So 5.5 million panels manufactured is a very conservative estimate, yet still gives us a 3.7 million in profit by year 3.
And as with any plan, we had a lot of risks and mitigation factors to consider when creating it. For example, slow adoption of the technology, high upfront costs, and also new tech requiring worker reskilling. We came up with a lot of mitigation plans, for example, integration pilots, a phase licensing model, and piloting with Chirp to create training modules.
So ideal PV prevents fires and protects firefighters, something that no other company does right now in this growing solar market, solar industry. And our licensing model helps create a profitable path from pilot testing with Chirp to large-scale adoption. And in short, we're not waiting for more homes to burn. Ideal PV is the airbag that the solar industry needs. Companies, communities, and the planet all need this technology, so let's make it happen.
So what you just heard was a shortened version of our full pitch that we gave in the competition and all of the process throughout. During this process of creating the pitch, ideating around the technology, and researching about this innovation, we had a lot of different takeaways from the experience that we felt mattered to us and to Mudd's message. We've connected with a strong and wide network of industry professionals, both through Mudd and externally, to talk with them and gain technical experience and exposure to the solar industry, and gain a look into the entrepreneurial mindset that's required to bring a technology to the market. And all of this represents an intersection to us between business engineering and public policy that we feel Mudd really gives us the freedom to explore. And here's a look at some possible next steps. We're not too sure where this project is going to take us in the future, But as the theme of this whole today is, with bold futures, we're looking towards hopefully building a bold future in this with some steps like this above and using that $2,000 grant to further this project.
Yeah, and we'd love to make some acknowledgements for everyone that also helped us along the way, including our advisors at Mudd, as well as other people within the Mudd community who also helped us, industry experts that took the time to actually speak with us and talk deeper into the specific problem during the pitch, and also after the pitch, where we met a lot of industry experts at the National Renewable Energy Lab in Colorado. Also, we'd like to thank the firefighters that we also contacted to discuss this issue, and also the people we met at the EnergyTech competition in the Department of Energy. And thank you. Feel free to reach out to us about any questions.